how would we find the answer to this question? How could we find the answer to this question? What have we done in the past, Terrell?
So we said x plus 3 is a factor. So what we did was we take the square root of 21 and then we divide by 2. We divide 10 by 2. Is that nice?
Not quite. Malik?
You could just do you play with x plus 3 and put those two into a binomial for it out.
Right, so in the past we FOILed, right? But today we're going to divide. So you're going to set up your equation like this. Go ahead and write that down. Yes, Mike? Because this is our divisor and this is our dividend.
So that's, after you're done writing that down, we'll leave it. That's an interesting question. This is happening yesterday too. We'll be okay. Alright, so Malik's question was, why are we doing this? So now let's take another example. Let's just say we have two numbers, A and B. How do we know if A is a factor of B when dividing? Can I ask that one more? How do we know if A is a factor of B? This is because kind of what we started talking about last week when we did long division. So remember back to that lesson. Real quick with your partner, just 30 seconds. How do you know if A is a factor of B? Or any two numbers, how do you know when you divide if they're a factor? It's the same thing. Dividing into the means no remainder. You're multiplying the
What do you ladies think? What was his question? How would you know that A is a factor of B? So how would you know?
Well, I remember he told us that...
Alright, bring it back up front. So to re-ask the question, how do we know if A is a factor of B? Angel, what do you say?
You said that we don't get no remainders.
So let's use all the words A and B. So when you divide...
When you divide A into B, you're left with no remainder.
And if you're left with no remainder...
What do we know?
The A is a factor of B.
Perfect. Awesome. Let's write that down. So you can do the A and B example and just kind of use that for all of these. So... Are you ready? Okay.
Yeah. A is a factor of B if there is no remainder.
Put a box and a star around no remainder.
So how this relates to the thing we did before with the other numbers is that when we finally divide everything out, the number that we get is not like a fraction. It's a factor of the number that's inside the little thingy.
Yep. So that's what we're going to be doing is we're checking to see if these things are factors. And the way we check is by dividing. So we're checking to see if x plus 3 is a factor of that other polynomial.
So this is another way of doing it besides Euler?
Yeah, but so the answer to your question is yes, and here's why. You could FOIL this. In a second, we're going to have one that looks like this. Can you use FOIL here?
No.
Why?
Because it's like the exponents are too big.
Right. So after you get past a quadratic, an x squared, you can't use the same process, so that's why we use this.
So, but you can use the square either.
Nope. Everything we know gets thrown out the window as soon as the exponent is higher than 3. That's why we spend so much time on quadratics, because there's so many options for how to solve it. As soon as you get past quadratic, all that's out the window, and that's why we have to use this.
So this whole
Just go with it.
is it because of this whole well then is this whole math class based off of polynomials then, or is this little subject?
It will be for the next month, yeah.
So what was the basis?
Quadratic.
But that's not a quadratic though. That's a
Right, but the quadratics leads you into polynomials, which is what we're doing now.
You said what?
Quadratics, like the unit on quadratics, leads us into polynomials, which is what we're doing now. Alright, we'll chat later.
Can't you just have an example of that?
No. Alright, keep going. No, you can't do that. That's not that easy. We're moving on. But good question.
Alright, so we're gonna solve this first. Some of you already might know the answers by being able to factor it or by being able to FOIL. But you're gonna look at this in the same way that you would look at a regular long division problem with numbers, like Mr. Vitale wrote on the board.
So write this one off to the side. We're going to be doing them both at the same time. So Miss Smith and I are going to go back and forth so you can kind of see how it's like the same idea.
So in a problem with just numbers, what would my first step be? Lou?
You wanna see, if 23 could go into 37?
But before that,
Oh, 3.
okay? Then, so no.
And then, if it can, then you'll do a 20, see if how many times 23 can go into 37. 1 again? Oh,
Okay.
2. Oh, wait, yeah, 1. Fine.
So we're gonna do the same thing here. But something very important to pay attention to, you only care about the first term, or the highest term, sorry, in your divisor. So we only care about the x, it doesn't matter about the plus 3, right? So how many times does x go into x squared? X times what equals x squared?
1.
X, right? So this x is going to go right here. I'll go out of the way. Yes, Malik?
Why wouldn't it be above the first term?
Why wouldn't it be above first term? Why maybe did I put it above my 10x? Shania,
Oh, no, never mind.
take a guess.
But you said the 3 doesn't matter, so I was gonna say something with 3.
Okay. Michael?
Oh, I was about to wait, because I thought there was like supposed to be 3 x's, so you distribute 2 of them to the first, and then the remaining.
Why? Okay. I think you said the same thing as Shania. Why do I match up my x here with my 10x? What is similar? It's like a 2-word answer. One.
It's just x, there's no exponent. Like,
Okay.
Yeah.
That's true. But why then did I put my x in that place? Why do I want it to match up? Chuck?
Did you take an X out of both?
Okay, that's not it's not false.
I mean, like X can be, it's like terms.
Exactly, it is like terms.
Perfect.
Because it is like terms, I'm putting my x above my 10x. Awesome.
Wait,
So-
what is like term?
My x and my 10x.
But what about X squared?
X squared is not like term. Yes.
I didn't figure out 2x.
What do you mean?
You said, you could take out 2x, but it's only the term x. Why did you do 2?
Where are you getting the 2x from?
No, because you had asked, like, how many times can x go into the other x?
How many times could x go into x squared, right? And we said x. That's where this x comes from.
Yeah, the other thing about that one is x times what gives you x squared. And that's what goes up there.
What will give us the first?
And we're gonna get to the next step. So over here on Mr. Butel's board, what would his next step be once he finds out that it goes in one time? Alex,
Subtracted by 23.
even before that, how'd you get that?
See how many times 22 goes into 37?
Okay, which is,
1.
and then what do you do? But why 23?
There's only, there's not
You just give it a step.
Yeah. Vanessa?
You multiply 23 by 1.
So you multiply 23 times 1. So here, I'm going to multiply x by x and x by 3x.
You're just distributing, so it's basically this.
So I multiplied my quotient so far by my divisor, yes.
So, so the 3 matters in the second step, but why doesn't it matter in the first step?
Do you know the reason behind it?
I mean, the same reason that like you're really kind of only seeing if 20 can go into 37. The 3 is just like the ones place. The ones place doesn't have as much of an impact on whether it goes in as the tens place, right? Like if you had to pick between the tens place and the ones place for how you determine whether it goes into 37, which one has a bigger impact, the tens place or the ones place? Same.
We gotta simplify, x and towards
This was our multiplication for the second step. So we multiplied x times x plus 3, just like we multiplied 23 times 1, and that's what goes in.
Well, I don't understand it, because if you, say we got 23, and, don't have to tell us outside of that, just to multiply for that, how would we know to do that to get that?
It's the same step. So you're multiplying your divisor by the first part of the quotient. 23 times 1 gives us 23. X times x plus 3 gives us x squared plus 3x.
So then from here, what would Mr. Butel do? And be very specific about the word you're going to use. What are we doing here? Admin. Subtracting is not quite the word that we're looking for. Not the difference, Kristen? Yes, you're going to take the opposite. And the reason that we prefaced that last week is because it really matters when we get to these binomials, right? Because we're going to be changing the signs. So I'm going to be taking the opposite. Here it's going to become a negative, and here it's also going to become a negative. From this point, you're going to simplify. X squared minus x squared is 0. 10x minus 3x is 7x. So once Mr. Butel has his 14, what is he going to do next? Come on. Bring down the 4. In the same manner, I'm going to bring down my 21. Yes.
But you gotta see first if 14 can go into 23, because 14 can't go into 23.
Yep.
Because like, what if it can't go into 23?
You were correct. Yep. So 23 can't go to 14. We skipped that step, but yeah, we got it.
Yes. Why did I change this to a negative? Good question. Why did I change this to a negative, George? Yes, we're taking the opposite of the original sign that was given. We were given a plus, we changed it to a negative.
So what if it was multiplication, you did the line?
There's not going to be a multiplication in this. You might have subtraction that you change to addition though.
In your problem, if you want to put a star and point it to that negative sign, the opposite, that is the thing that most people have trouble with in this process. Most people just forget to take the negative of the second one. Everyone remembers to take negative of the first one. A lot of people, even today we've been practicing, have been forgetting to take the negative of the second one. So make sure you put a star and that you put a star to both of them in your problem. Mine, I only have one, but like that you put it to the negative and both of them you're taking the opposite. Hang on a second.
Alright, from here, or from that step, what would Mr. Butel do? Alex.
How many times does 23 go into 44?
Great, so we're going to do the same thing here. How many times does my x go into 7x? Or x times what number is going to give me 7x? Angel.
7.
7. So, plus 7. Yes. Because that's what goes right here. Whatever, it's, what number is going to give me 7x? 7. So, 7. From here, I'm going to then multiply my 7 by my x and my 7 by my 3 to give me 7x plus 21. From, yes, yes?
So why do you only distribute the x, like that x, the x what you want, you use a 3, you know what I'm saying?
I don't know what you're saying.
So you see how you only use x to figure out what went to 7x, so why don't you do how many times the tree going to 21? You can't do that?
No, because it won't always evenly go into this. Yeah, you're just looking at the first term.
Yeah. So when you have this thing set up, this will always be the same.